Alright, time for the math. Easy solution. We're going to discuss some very easy to understand but very useful trigonometric identities to look at. These basically, these two ones are cosine of an angle plus 2 pi is going to be cos of that angle. Same with sine. It's going to be the sine of that angle. And then these ones with half angles, if you have pi over 2, which is 90 degrees, this is 360, is pi over 2, 90. Subtract that angle is going to equal to sine of that. If it's cos, and if it's sine, it's going to be switch of this. So basically, to prove, let's prove this set first. Go on. So here, proof of these ones. So basically, so if we draw x and y axis right here, there's y, there's the x axis right here, and then if we draw let's just draw an angle. We'll just go from here to here, and we'll call this angle. Here, this is just theta. So if this is theta, then basically. Doing the cosine just adjacent over hypotenuse, and then we'll call this opposite. Just so opposite over hypotenuse, or OP, is sine. And then if you add the 2 pi to it, let's just go to an extra angle. Let's say 2 pi. 2 pi is just 360 degrees, so 2 pi. So if you go 360 degrees right here. And then if we go beyond that to this angle, this is basically now 2 pi plus theta, because this goes back to this line. So now it's going to be the same terminal line, or the same where we get the ratios from. So basically from here we just proved this equation. So this is a proof just by looking at it, because it goes back to the same line, so the ratios are going to be the same. This is proof, and ratios are the same. Okay, so that's an easy one, just look at it. So now let's just prove these two set of equations right here. Okay, so if we draw another set here, x and y axis here, this is x, that's y, and this is basically, so pi over 2 is 90 degrees. So just write pi over 2 is equal to 90 degrees. So when this is 90 degrees, so this is, we'll just call this pi over 2. So now if we were to draw an angle just in between it somewhere, let's say this is a random angle. Okay, so this angle right here, this one we'll call this theta, this is pi over 2. So then this angle between these two is just the difference of it, so pi over 2 minus theta. Yeah. So now if we just draw the triangle so we get the ratios in, so we'll have it something like this. So if we call this length A, this length B, this length C, and then this is going to be B, this is going to be A. This is the same lengths. So basically then we just compare the ratios. So we'll go here, so basically cosine of pi over 2, cosine of pi over 2 minus this theta is going to be adjacent. In this case it's this, is A over C. So then there's going to be A over C. And then if we look at sine theta, sine pi over 2 minus theta, that's going to be the opposite. In this case, opposite is B. Hypotenuse is the same for both, so it's C. So it's going to be B over C. And then we just compare these ones here. So now if we look at this one, we'll just go cosine of theta. This is equal to, well, adjacent is B, so it's going to be B over C. And sine of theta is just going to equal to, well, opposite over hypotenuse, so A over C. So then if we just compare them, these two equal, and these two equal. This is B over C, B over C, A over C. So there's our proof. So basically we get cosine pi over 2 minus theta is equal to, okay, so cosine pi over 2 minus theta is equal to sine theta, and sine theta minus theta is equal to cos theta. And you can also see this if we look at the graph of this one. I'll show you, it's just a shift in the graph. So if you were to graph it, so we just draw the y and x axis here. This is x. So now if we draw a sine, let's just draw a sine, how it would look like. Sine would look something like this. It would be something like that. It's a bit off, but yeah, so this is sine theta. And then if we look at this one, this is a shift in this equation. So at this point, let's say here, this is say the starting point of the sine of the xy axis, so sine 0. So if we were to make sine pi over 2 minus theta equals to the starting point, let's say sine 0, then this is only true if pi over 2, if you set this to equal to 0, so these ones are going to equal to 0, and then pi is equal to, theta is equal to pi over 2, or 90 degrees. So that's where we kind of start off, and it's a shift in the actual graph of sine. So it would be something like this. So you would start off here. This is pi over 2. So now this is where you would start, and then you would have your own. So then you would have, this is the x-axis here. So you would start here, and then the graph would look something like this. This we'll call this y prime, or the new one. And then so that if you were to shift it here, and you would have this one would be basically cos. This is also. This is so you'll have y prime is equal to cos theta. So this is basically just cos, because that's what cos, or just a shift in sine pi over 2 minus theta. So but that's all you're doing is shifting it. So you're shifting this y axis there, and then if you would get rid of this sine one, you just have it like this. So it would be exactly the same as cosine. So this would be cosine theta, or sine. So that's basically all you're doing. So that's if you were to get rid of this one. So basically all you're doing is shifting where the sine curve is. Oh, well, that's all for today. I guess we learned. These are some useful trig identities, and they're actually pretty easy to prove and whatnot. This is just by looking at it. It's gonna be the same once the proof is the ratios are the same. So that's this proof, or this part there. Well, thanks for watching, and stay tuned for another math easy solution.